There is a place in Wyoming where people drive for hours just to stand in front of something that doesn't quite make sense at first glance. It rises suddenly from the flatland, massive, silent, and strangely familiar. This place is called Devil's Tower, and according to geology, it is a volcanic formation, an ancient column of magma that cooled underground and was later revealed as the surrounding rock slowly eroded away over millions of years. That explanation is accepted. It's taught, documented, and supported by geological principles. But when you actually look at it, not through textbooks, not through diagrams, but with your own eyes, it becomes harder to ignore a very simple observation. It looks like a tree. Stump. Not slightly. Not in a vague or imaginative way. The resemblance is striking. The vertical columns that run along its sides look like fibers. The top is flat, almost worn down. Around the base, broken pieces of the same material lie scattered like fragments that once belonged to a larger whole. The similarity is so strong that once you notice it, it becomes difficult to unsee. Geologists explain the columns as a natural result of cooling basalt. When lava cools, it contracts and fractures into polygonal shapes, often forming hexagonal columns. This is not unique to one place. Similar structures can be seen at Giant's Causeway, where thousands of tightly packed columns form a geometric landscape along the coast. The science behind this is real. It's repeatable. It's observable. But the question that lingers isn't about whether basalt can form columns. It clearly can. The question is why these formations sometimes resemble organic structures so precisely. And more importantly, why do we find similar patterns in completely different parts of the world? Take Shiprock, for example. It rises sharply from the desert, surrounded by long, thin ridges that extend outward across the land. Officially, these are volcanic dikes, remnants of magma that filled cracks in the surrounding rock and hardened over time. It fits the model. It makes sense within geology. But visually, it almost looks like something rooted, something that once extended downward and outward before solidifying. Then there are the tepuis, massive tabletop mountains rising above the jungle. Their tops are flat, their sides nearly vertical, and their bases often circular. These formations are explained as remnants of ancient plateaus, shaped by erosion over immense spans of time. Again, the explanation works. But when you step back and look at all of these formations together, Devil's Tower, Shiprock, the Tepuis, and others across the globe, you start to notice a pattern. Not proof, not evidence of something hidden, but a pattern that feels consistent enough to raise curiosity. Some people have proposed an alternative idea. Not one supported by mainstream science, but one that continues to circulate in discussions and theories. The idea suggests that these formations resemble biological structures because they may preserve shapes that feel organic, like the base of something that once grew. It's a bold thought, and it immediately runs into a major problem. There is no direct evidence to support it, no preserved tissue, no cellular confirmation, no microscopic structures that indicate biological origin. Without that, the idea remains speculation. Still, the curiosity doesn't disappear so easily. Part of it comes from what we know about Earth's past. Hundreds of millions of years ago, during the Carboniferous period, oxygen levels were much higher than they are today. This allowed for the existence of much larger organisms, giant insects, massive plant life, dense forests that stretched across continents. These forests are believed to have produced enormous amounts of oxygen through photosynthesis. Over time, much of this plant material became buried and transformed into coal, which we still use today. That is the accepted explanation. But some researchers have pointed out that the scale of oxygen production during that time is still a complex topic. The numbers are large, the systems are complicated, and while current models explain it, they also leave room for deeper investigation. This doesn't mean there were trees miles tall. There is no evidence for that. But it does highlight something important. Our understanding of Earth's deep past is still evolving. When organic material becomes fossilized through a process called permineralization, minerals replace the original biological structure while preserving its form. Petrified wood is a clear example. What was once living tissue becomes stone, but its internal structure remains visible under the right conditions. This process is well understood, and it shows that nature can preserve structure in ways that blur the line between what was once alive and what is now rock. However, scaling that process up to the size of mountains is where the theory loses support. There is simply no verified example of anything on that scale undergoing such a transformation. No evidence has been found to suggest it ever happened. So where does that leave us? Somewhere between explanation and perception. Because the truth is humans are incredibly good at recognizing patterns. It's part of how we understand the world. This tendency is known as pareidolia, the ability to see familiar shapes in unfamiliar places. It's why we see faces in clouds, animals in shadows, and meaning in randomness. And it may be the reason these rock formations feel so familiar. At the same time, it's also worth acknowledging that science doesn't investigate every idea equally. Research is guided by funding, by established frameworks, and by what can be tested within existing systems. That's not a flaw. It's simply how structured inquiry works. Technologies like ground scanning and internal imaging have advanced significantly. They are capable of revealing hidden structures within rock formations. These tools have been used in archaeology, engineering, and geology. So far, when applied, they continue to support the existing geological explanations. Still, the visual resemblance remains, and that's where the real fascination lies. Not necessarily in proving an alternative theory, but in recognizing how perception and reality can overlap in unexpected ways. A massive rock formation stands in the middle of Wyoming. It has been there for millions of years. It has been studied, measured, photographed, and explained. And yet, for many people who see it for the first time, the same thought appears almost instantly. It looks like something that used to be alive. Not because it is, but because the human mind is built to search for patterns, to connect the unknown with the familiar, and to ask questions, even when the answers already exist. And maybe that's the most important part of all. Not the theory, not the debate, but the fact that something as simple as a rock formation can still make us stop, look closer, and wonder if there's more to the story than what we've been told.